All right, we're going to do a couple of problems from lesson 3 that have to do with exponential functions and what their graphs look like, okay? So the first one we're going to do here, it gives us an equation. It says y is equal to negative 3 times 4/5 to the x power. So what we want to do, what it's asking us is to say, which of these color-coded functions actually matches the equation? Because we know every equation has its very own graph, right? But we want to make sure that we can tell which of these graphs actually represents the equation that it's given to us. So what I like to do is make an x and y table. So this will help us be able to figure it out a little better. So let's see here. If I put a 0 in for x, then that's going to be like this. Y is equal to negative 3 times 4/5 to the, instead of x, it's going to be to the 0 power. We know that anything to the 0 power is 1. So this is going to be like negative 3, whoops, that says negative 3 times 1, which is just equal to negative 3. So when x is 0, we get that y is negative 3 in our real function. This, of course, corresponds to the point 0, negative 3. So now we look at our graphs and see which of them have this point. It looks okay when x is 0 and we go down 1, 2, 3. All right, there's only 2 candidates now. We know that it's got to be this one or this one. We can ignore this check mark and pretend like we don't already know the answer. So let's pick another number and see what we get in our function, and then that will help us determine the final answer. Okay, I like to pick pretty easy things for x, so I'm going to just choose x to equal 1. And that means that I'm going to have to do another equation to see what we get for y. So that will just be equals negative 3 times 4/5. And then remember, where the x is up here, I'm replacing it with the number 1. Anything to the first power is equal to itself. So I know that this is just equal to negative 3 times 4/5. Sorry, my 4 and 5 look kind of funny. When I do that multiplication, I get that is equal to negative 12/5, which is equal to negative 2.4. So a little less than 2.5. So let's go ahead and put that there, negative 2.4. Okay, so that means when x is 1, so if we go over one spot, well, that's at 1.2, look at that. Okay, so not quite to 1.2. Then we'll have to go down 2.4, which looks like we're going to get a point right on this yellow graph. You see that? Right there. This corresponded, I should have written this to this point, 1, negative 2.4. So we were looking to see which of the graphs contained this point and this point. And it turned out that yellow was our winner. So maybe I should circle them in yellow. So our answer here will be j of x. Let's go ahead and circle that answer, because it contains that point there and the other one that we required it earlier from our table. Okay, now the next question down here says choose all the functions for which f of x is greater than 0 for all values in the domain. So here we only have a couple options that we're going to check, because I didn't cut out the whole problem, but it will give you an idea of how to do it. We want to find a function that is bigger than 0 for every number that we put in for x. So let's talk about domain for a second. When it talks about values in the domain, that just means values that we pick for x. Like in the last problem that we did, the domain that we chose was just 0 and 1 because those were the x values that we chose. So here, it's saying we want to find the function that no matter what we put in for x, it always gives us a positive number for y. So let's take a look. The first one we have is p of x. And it says that p of x is equal to -3 times 1 over 6 to the x power. Now, could we think of a value we could put in for x and it would give us a negative number? Well, I think so. If we put 0 in for x, so if we take p of 0, then we'll have -3 times 1 divided by 6 to the 0 power. We know that anything to the 0 power is equal to 1. So this will just equal -3 times 1. And that's -3, isn't it? So we already violated our one rule, is that f of x has to be greater than 0 or positive. So this one doesn't work. We know that this cannot be our correct answer. That only leaves us one option. You may have had to check other ones. Like I said, I cut off some of the other answers here, but that gives you an idea of how to do this type of problem. Check values in a domain. Anyway, I hope that helps you out and that you're having a good Wednesday. Thanks.